Hey there, everybody. This is, I don't remember which one this is, fourth or fifth so far. Thomas Shanks was supposed to be doing his presentation, but he wanted a little bit more time to prep. So Rick Ulland graciously agreed to swap with him. Hey, these are both about networking. So Rick's here to talk about his CoCoIO card, and we also have Henry Strickland here with his slick OS 9 boot from the network. And as well, we also have Frederick working on his 6309 system, and Grant Leedy's dropped in, and myself. So let me throw this over to Rick, and you can carry it away.
Such a deal. The screen I'm seeing is delayed, and I'm going, why hasn't it changed yet? Sorry, folks. Anyway, I guess I'll start with if you haven't seen the hardware yet, it's a prepared text that I am no longer able to pull up. Here we go. It is this one. Demon, please. So what we've done now is there's an EEPROM there that can be written from the CoCo. So you can actually boot from it, change the boot yourself. There's no need to have any other computer for any other reason to do anything to it, including connect to the Ethernet. Basically, our difference is we're doing things on the CoCo, not for the CoCo. So you plug an Ethernet cable in and you're done. As you can tell, there's not a heck of a lot of processing here. There's, the Ethernet chip and some decoding. So the CoCo can't do everything. We're probably going to have some kind of offsite server to help spoon feed it things from the great wide world. The difference being that not every user needs to provide that. The CoCo could just connect out to us and we'll sort of spoon feed it whatever it needs to keep going. Let's see. Henry, would you like to talk about the boot side of things right away, because that's actually the news?
Hey, Rick, why don't you jump right in here? A few people probably don't know what the CoCoIO is, so you should probably give it a 25-word preference here. And this is like your third or fourth revision now, right?
Oh, okay. Yeah, I guess I'm assuming too many things. Yeah, the idea was to make an Ethernet card for the CoCo without having a Pi or a PC or a serial. So just Ethernet on the CoCo. So this is like my fourth try at it, including chips that died in the COVID crash and other things.
And this
So
one has
this
a boot ROM, so you can do a Pixie boot.
pretty much. In fact, we'll you're going to have to say how to pronounce the mountain because I do not know. But yeah, the idea is we're taking it down to the basics here. So, for instance, OS 9 can use TCP, UDP, just raw internet connections to do things without having some intermediary do them for it. And I think that's the interesting part. So, Henry's written several utilities. I'll call them the F dot utils for lack of a better word, that do all of the heavy lifting. And I've written a couple of sort of syntactical sugar programs to, well, I'll show you when we get to that. But basically, it's trying to do Ethernet on the CoCo as cheaply and compactly as possible. And we haven't quite got to the cheap part yet, but that's coming. So anyway, tell us about this mountain.
Okay, you're talking about the software that I've been writing.
Yes.
Rick has provided the hardware. He put this on sale, I don't know what, more than a year ago, and called it the Founders Edition. And the meaning of Founders Edition is that you get this piece of hardware, but you have to figure out how to use it. There's no software for it yet. So this is how he crowdsourced people to help do stuff with it. And we know that Mikey has also had success in writing some software and running on it, and you've seen that on Coco Nation in the past. But I tried my hand at it as well, And I started out, what did I do? I started out with little basic programs, uh, just poking here and reading from there until got some confidence that I understood how the registers worked. But then pretty soon I dove in writing code in OS 9 operating system, or Nitros 9, which is now the community maintained version, and using C. So have a couple of different C compilers, and I believe CMOC is the one that I used. But I haven't used these f.dot utilities in so long, but there's an f.config which tells the WizNet, the chip that actually does the internet stuff is a Korean chip called the WizNet that's designed for the Internet of Things. And we use the W5100S version of this chip, which is capable of doing ARP, of doing ping, of letting you open up to 4 sockets, which can be UDP sockets or TCP sockets. And they the TCP could either be a client or it can be a server, but there's a bit of a limitation there. If it's a server, it accepts one connection, and when you close it, it's gone. You'd have
Bye-bye.
to open it up to get another connection. So not quite as general purpose as a general purpose Ethernet card is, but the fact that it does retries and things for you automatically does make it much easier to write at least TCP clients and servers using it. So f.config tells it what its IP address is, what its network mask is, and what its router is. And that's like the absolute fundamental things you have to teach a Ethernet card if you're going to do a IPv4 stack on top of it. And let's see, I believe Mikey had a version that used a config file, but I took the no config file philosophy for writing these tools. So if you need to tell it anything extra, it's going to be a dash option on the command line. And the idea is people can rewrap these with shell scripts that call them with their own command line
Well,
parameters if they
maybe I
need
should
to.
maybe I should jump in at this point
Yeah,
with this thing. So I took your config and came up with just a generic if up. So you can use a sys interfaces file as small as just specifying it's DHCP and this is my hardware address.
sure. Yeah,
Or you can
that's
just go
exactly.
or you can just go full Linux and say here's a static address for Ethernet connection. Here's a different ETH1 is actually a encapsulated serial. Whatever you need to do, specified in this file. It's Unix. Everybody knows how to format it, so there's nothing new to learn. And then I really kind of ran with fdig, and we've got a host command that actually does sort of a recursive name thing. So if you get C names, it'll ask again until it finally finds an A record. And it uses the host file. It says host file, again, very Linux-like. We're going to define, well, I hope to define host names in the 1.700 thing for however many ports you need to define a host name for. So you can, set a logical name for your DH to show up on your DHCP server, whatever you need to do there. Then there are your traditional user overrides where we won't even ask DNS about these addresses. We use those numbers, we'll trust them. And then below the fold here, the little blank line, I've actually got a cache. So once we dig a valid address, we'll store it here. If in the future it doesn't work, we'll delete it and try again. And if it doesn't work a second time, we'll just store it again. And okay, that's it. And site's down right now. But otherwise, it gives us a rudimentary cache there. So we've kind of gone a long way towards networking on Linux, and I don't know a dang thing about writing drivers for Linux. This is all basic online stuff and it works beautifully. So I think using the list of dot things that you have going here, a lot of people will be able to do a lot of things. I mean, everyone wants a clock. Here we go, FNTP. we based hosts on FDIG. You've got a trivial FTP going and send and receive. So thanks for that much. And we haven't even got to the whole starting up from nowhere bit yet.
Yeah. So you can see that I've gone the Unix philosophy of small, simple tools that can be recombined and built on top of. So you've started building out the files to store parameters like that, and you could have also built a GUI to let you edit these things, like all the modern operating systems have GUIs now to let you type in your IP addresses and stuff
Right.
like that. Yeah. But it was a lot of fun writing those little tools and going back and reading the original RFCs, like for the network time protocol. I I actually enjoy little puzzles like figuring out their epic starts in 1900 instead of 1970, and doing the arithmetic to convert it into OS 9 just doesn't use a big integer for seconds. It uses a 5 or 6 tuple of year, month, date, hour, minute, second, like that. So um, let's see what else. DHCP was another fun one to get going because it didn't work and it didn't work and it didn't work and it didn't work. And I'm looking with TCP dump to see if I'm getting any kind of response back from the server. And then all of a sudden, one more little change and it worked just completely. And
there's, there's still a wrinkle in it. It doesn't like having two DHCP servers stacked if one of them is a D-Link, which is a very specific complaint to have, but there are certain combinations of stacked DHCP servers that it can't get through.
interesting. Okay.
Or
Yeah.
that it can't, let me take that back. It can get through, the boot can't get through.
Okay.
So I'll get the hanging plus, 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 plus. But if I boot up OS 9, if DHCP will work fine, and I can go to Curtis's website. In fact,
Yeah, so
may demo that later.
what Rick is talking about is the boot ROM. There's a so the boot ROM is another topic. We've been talking about the OS 9 commands, and there's one of did I do yeah, I think I did an f dot DHCP, didn't I, Rick?
Well, yeah, that's one of the
Yeah,
two things that IFUP
yeah,
uses to get out to take its head out of it. Yeah.
yeah. I mean, it from my point of view, it should be that only one DHCP answers my questions, and whatever it tells me is the route, and whatever
That's
it
yeah.
tells
Well,
me
yeah,
is
and
the net mask is the net mask, and if
that should
not,
work. I mean,
yeah, if
that
it's not,
should
you're
work.
lying to me, and no wonder it's going to get stuck.
But let's see what other weird thing.
Oh, yeah, f.tix, that just went by. That's a really useful thing. There is a free running counter on the WizNet chip that counts in 0.1 microseconds. So it'll count to 10 in 1 microsecond. And you can use that as I hate to call it, well, yeah, it's real time. And it's not a wall clock in the sense that you can change it and set it and correct it with the rest of the world. But it is a counter that's really good to use for delays.
Right.
If you don't want to care whether you're on a 1 megahertz or a 2 megahertz system, and other things like that, where little delay loops where you count can go faster on a 6309 than on a anyway. I've used that in a number of places, and I also use it as a source of randomness. It's only 16 bits, so it's not really cryptographic random, but it's good enough to choose a local port for making connections out. So that's kind of a neat feature of that chip. F.ping. that's useful. It's cool to see that
Right.
your little Coco can go ping something way out on the net. F.arp. Most mortals don't have to ever use that, but that is like a starting point to
It's
get
one of them core
the
pieces
stack
that
up and
you,
going.
right?
Yeah. So
Mm.
people have heard of Netcat, and I've got a couple versions that are kind of like Netcat. I see F.receive down there, and there's an F.send that I think those are UDP. In fact, I think most of these
Yeah,
F things are UDP. I decided to do UDP protocols first because other people were doing TCP stuff, and there's great fun that you can have in the UDP world. TGET is a TFTP, Trivial File Transfer Protocol client that just gets a file, and there's also there could be a tput if you wanted to put it up to a server, but looks like tget gets the address of the server, the IP address, and the default port number is 69, and then the remote file to fetch and the local file to save it into. F.dump is kind of like TCP dump. It puts it into promiscuous mode to get all packets that are not going to another socket. If there's a socket open that's listening on something, it'll get it. But F.dump, you can open up socket 0 promiscuously, and that just lets me dump traffic on the net, just like TCP dump does. And it is freaky weird when your little Coco does something that you're used to doing on a big Unix machine.
Right. And it's doing it by itself. It's not, asking something else to do it for it. It's just
That's right. That's a strong point that I've got other stuff going on where stuff is done for you over on a server somewhere. But this set of tools right here is really empowering the Coco to do internet things by itself. See, I'll make another comment about these commands. We have not put the Berkeley socket interface into the operating system kernel yet. These things are doing raw peeks and pokes to the WizNet chip because we know it's mapped into page FF up at an address like FF68 or something. And it was just a lot easier to get started doing these in the commands themselves instead of trying to start out defining new operating system calls and layers of the operating system. And really in level 2, there's not a lot of space to put a whole lot of more stuff into the kernel if you're going to have some devices, because I had already tried writing a fuse file system, and doing a file system like that took up a lot of space. These commands also, I'll make a comment, they're bloated right now. I'm using CMOC, and I'm not using it real smartly. And if you look at my make files, you see that I've experimented with trimming down the size of these files a good bit. But CMOC is what I'm going to call a naive compiler. It does not have the SSA, static single assignment format that's used in modern compilers that really do good optimizations. GCC, however, does, but GCC for the 1609 right now has this bug that it doesn't do position independent code, or it has lots of errors if it tries. And position independent code is the bread and butter of OS 9, and so I have to go back to CMOC and use it. But yeah, thanks to is it Pierre Sarrazin that wrote the CMOC? Yeah, thanks to him, because that's been a godsend to be able to write in C instead of in assembly. I mean, if you look at the error rate I have in C, it's bad enough. The errors I would make in assembly would just take me weeks to debug.
Well, the important thing is these things do work, and I've been messing with them and actually doing things, and actually integrating it with my basic online application, that web browser thing, which is a combination of using your stuff to get a lot of work done and then just poking at the chip at other times. So there's really people want to write software. We've got enough to start with now where you don't have to do everything yourself. You can say, hey, bring up, make me a connection to here and let me know what it is, and I'll work with that. So
Now these are specifically on OS2 level 9 at this point, or Nitrous 9 level 2 at this point, right?
These FDOT commands will work on level 1 as well.
Oh, okay.
Because they're not in the operating system.
Right.
All they have to do is load, and as long as you have enough memory to load these bloated commands, then they
life is
do
good.
their
they can
job and
take
then quit.
the WisNet
Right.
chip. Yeah.
Okay.
And I say bloated as in they're taking like 3 of the 8K chunks that you think of under level 2, and they should be taking 1.
Right.
Oh,
But
before we get
make it work before we make it small and fast.
Yep. Exactly.
before we get too far away from this, since I've encouraged everyone to use this stuff, when you do use it, here's a trick to save some time. You go to the DDSys interfaces file and set DHCP once, and you run it, and then you run ifconfig, which is another utility that's available on my GitHub, and write those numbers down and put them in the static file, and then change it to static. And your DHCP server will never know that you're sneaking in and not even asking it. And you won't spend the time to load the data and get online every time you reboot. And if it ever quits, you just change back to DHCP and it'll give you another number. Anyway, just something I learned I thought shouldn't get away while I had the thing right in my face.
Both my routers allow me to do reservations, so I can, once I have a MAC address, then I can assign it a particular IP address every time.
But it's interesting that a lot of times on a home router, you don't even have to worry about it.
Mm-hmm.
It's going to give you a number, and unless it exhausts, it's never going to change it. So you can just assume that it's yours to use. Anyway,
we're actually relying on that right now. Like, we don't have any daemon that's going to regain the lease. We just
exactly. So what's the, why not just call it static and put the number in there? And hey, if I ever leave home, I'll change it back to DHCP and it'll work wherever I go, usually for some time.
I have a question from L. Curtis Boyle. He says, does CMOC compile better than the native OS 9 compiler, or DCC, which is a bit more optimized and expanded?
I don't have a good answer, but I have a small conjecture. My conjecture is that since CMOC runs in Linux or Unix or something other than OS 9, it's not memory limited like a CoCo is, that it might have a lot more peephole optimizations in it than the native compilers. Sadly, I have not messed with the native compilers so much. There's a little bit of a barrier that I've been writing in ANSI style C instead of KNR style C, and I'm sure there's KNRifiers or deansifiers that I could run it through, and I've seen people use macros to write function declarations that work both ways. And if someone gets free time and wants to try this out, it'd be cool to know.
Curtis says that DCC has more ANSI stuff in it, but it's not complete.
Yeah, yeah, getting one version working takes enough time that I haven't gotten around to
trying other versions. Yep,
to try lots of others. Yeah. Okay, good question, Curtis. Thanks. And then if anyone wants to explore this, I'm open to working with you.
Do you have this on your one of your Git repos?
Yeah. Everything we've talked about is in a repository named FROB.io, FROB.io. I took the IO from Rick's cards name, the CoCoIO, and FROB from the old MIT verb to frobnicate. And
Gotcha. Yeah, I have URLs for those, so I will post
Yeah,
those.
and then my GitHub is named Strick Yak. Strick comes from my name, and yak is my species, and so you'll find it there.
Curtis says,
That's
"Yeah, I
so
totally agree. He was just curious."
Mm-hmm. And I know that Deke has put so much time into the compiler. It makes me sad I haven't been using it.
like you say, it's working and it can always be changed. You know,
Yeah.
you got to start somewhere.
So
Speaking
there's
of,
many aspects to this FrobIO repository. There's lots of little subdirectories. All the current stuff is under Frob3. There's a Frob2 which was usable as well, but Frob3 is where all the new stuff is. And so Rick is now showing you the boot ROM, which is a completely different thing from OS 9. This is entirely a CoCo thing. When a CoCo cartridge is plugged in, it has a couple of ways to get the attention of Basics ROM to say, hey, here's an extra ROM. I want you to boot me. And if you're in HDB DOS on a CoCo STC, you can take advantage of that boot ROM, which is what he was just doing, because I saw him say run at. And
and you know where we're headed. We're headed to OS 9.
okay, yeah. So I threw together in the last week before Cocoa Fest last May, I needed a some way to choose what it is that you want to run. And I decided to try out a video text model or teletext model where every number has a page on it, but a page also can be launchable or it can be an index of other pages. And so it presents you those menus and you can type the numbers and navigate the way down. And you're booting Ease of Use Edition. You doing this across the grand internet or
Yeah, this is from my bedroom in Milwaukee to New York City.
to the global server? Yeah, so I run a global server that's in DigitalOcean, that's in the New York City 1 data center of DigitalOcean. And so Rick is in Wisconsin, and it really shows up that we're doing tiny packets, like 256 bytes at a time is the size that OS 9 does its disk IO in. And see, this is coming off of a virtual disk drive, which is hosted in that server in New York. And so fetching little packets at a time, and it's a synchronous protocol, so it's waiting for a reply before it does the next one. There's a lot of room for optimization. We'll make this go faster, because you're looking at this and thinking, when I boot up OS 9 Ease of Use, you know, it runs 5 times faster than this, and you're right.
You haven't tried a real floppy drive recently, have
It's on my list of things to get to. Yes, to
you?
get.
To avoid.
I've got some floppy stuff to try. Yeah. Um, but you can also run this same server code. It's in that FrobIO repository, and if you do the whole build, you can run the reposit. You can run a server on your LAN on a Linux box. Is this? We got, yeah, Boise got this working on Mac OS, and you could do it certainly on Windows if you're in a subsystem for Linux on Windows, like you use their Ubuntu. Anyway, it's much faster if you've got your own server. And I want to build a version of the server which is just a cache as well, so that it understands what requests you're making, and it fetches new stuff out of New York, but it caches results and makes things faster for you. So you can see /DD is a virtual block device. The device driver is fairly small. It just needs to be able to request a 256 byte packet to read or to send a 256 byte packet to write. And if you do a dir-e-x, you'll start to see some of the round trip times making it slow again, because we jump around from sector to sector a lot in order to do that. But it's the G shell works if you've if you've got your joysticks, you can do all that stuff with it. It's pretty neat. This is a throwaway disk image. If you reboot your machine, changes you make on this are not going to be there. And an easy fix that I need to do and just haven't done yet is to give you a personal drive /D1/D2/D3 that persist. And we're starting to put a host name and a secret password at the tail end of your ROM, so that your machine would be able to present these credentials or do a challenge response authentication protocol or something like that, and authenticate you to the server and let you get at your files there. That should certainly be going by CoCoFest, because it's just another block device.
Because one of the things we've got to do is push the security off the CoCo out into space, because the CoCo can't create any security. It can only, recite a hash or something. Here's my ID and here's my secret.
Yeah, I don't think most people would want to run it, but I've got a strong urge to give you an encrypted option if you want it. RC4 should be usable on a CoCo.
We're kind of counting on obscurity, aren't we?
It would certainly be slower. Also, there's public key crypto using what is it? The knapsack algorithm. The knapsack algorithm is thoroughly discredited for cryptography today, but if we're going back to the era, there's source code in the old Unix, back when it was on PDP-11s, which is a 16-bit big Indian machine with a 16-bit integer in C, just like our situation. So I could probably lift that code written by Ken Thompson or Dennis Ritchie long ago from the secret mail package that was in old Unix, and use it for a public key demo. Not that you'd want to trust anything in on the modern internet with it, but
it's mainly to keep
demo.
two CoCoists from messing with each other's online game or something.
Yeah.
It's not for stopping PCs.
Yeah.
So Curtis said that all the commands are being pulled across from the server then. So when you execute a command from the commands folder, it's
yeah, everything we did here was coming over the wire.
The disk operations are exactly the same as they would be on your CoCo SDC or on your floppy or any other.
Had to just load procs.
But this one is going out the WizNet chip out, the CoCoIO Ethernet card.
So G shell run?
G shell does run.
Yeah, I can't get there for now for my network situation at the moment, but I should have thought to do that. It would have been interesting to see how long it takes to actually, render a directory.
I mean, when you're ready to throw this one away, go ahead and type G shell and give it 30 seconds to turn red or.
All right. Well, I don't have a connection right now, so I'm having to rely on videos.
Oh, okay.
Did you break your internet, Rick?
Well, I have to unplug everything and run a wire directly to the CoCo for the outside connection to work for some reason. It won't. I can't go through the little router that's routing everything in this room right now, so that kind of messes up many things. I'll have to come up with a better solution, like another long wire into the back room.
Mm-hmm.
So in any
More
case,
wires, that'll fix it.
Let's see what else we do here. Just some videos demo.
Yeah.
Oh, I picked a different thing in your boot. The life.
Yeah. So when we first got the Ethernet cards working, naturally the questions are, how reliable are they? Like how long before it makes a mistake? And how fast will they go? And so this demo number 11, do you happen to be on a CoCo 3 and a 6309, Rick?
When I did this, I don't know.
Okay. Oh, this is filmed.
Yep, all I can live demo is like I can boot OS 9 and connect to like Curtis's web server from here.
Oh, okay, okay.
And that's
What
the
I was
ports.
that's what I was
Okay.
totally missing. Okay.
But I can't do the direct through two router. It doesn't like the two routers in a row
Yeah.
for whatever reason.
So when I run my own server on a LAN on a Linux box, or you could do it on a Raspberry Pi, that would be a very nice configuration to make it easy to run a Raspberry Pi for your local server. You can I usually use Class A reserve network 10, and your server gets the address 10.23.23.23. And why am I saying this? Because in the boot ROM, if you want to change your CPU to be 2 megahertz instead of 1 megahertz on a CoCo 3, you use the command Q for quick. And then if you want to say go into native 6309 mode, you use the letter N command for native. And once you've done that, it's no longer using the DHCP or the automatic LAN discovery. So then you say A to mean I want to connect to a server on the network 10 address and launch from there. And then you can run live, more than twice as fast. And we're getting easily 75 kilobytes per second. What's 75 times 8? Anyway, 400 kilobits per second in these live demos. And that's without doing 6309 optimizations, where we can turn off interrupts for the transfer of a dozen or some handful of bytes. If you don't want to turn off interrupts too long, there's this bug in the 6309 that it misses a beat if an interrupt occurs during the block transfer command out of an IO port, which is how you read the bytes out of the WizNet chip. But anyway, there's ways to speed things up with that. So someday I'll have better maximum rate that I've achieved to talk about.
I think it's just interesting. Oh yeah, I suppose we should run the Radio Shack ad. Although we need the audio. Oh no. And I found it. Radio Shack's color computer 2 on sale for just $99.95. So yeah, you can watch Radio Shack ads on a CoCo now.
So that works on a CoCo 3. It's using 16 color mode with 128 pixels across and 96 pixels down, I believe. And I downloaded videos from YouTube. I can't tell you how, but once I got them, I used the ffmpeg command to resize them, to change the frame rate, and to provide a color map. And so there's 16 colors that I've chosen out of the 64 possible colors that you can do on the CoCo 3. We're only allowed to do 16 at a time. And a future version of this should really figure out what the best colors are for every frame and change the color palette every frame. But right
That's what I was thinking. You're going to end up having to invent keyframes and color
now,
sets and
yeah, but right
for
now,
somebody, but you kind of plowed the, you've shown the way here.
yeah. So anyway, FFmpeg chooses from these 16 colors, and I don't know if there's some extra dithering options that would make this look better. We should look into that. But that's one pass with FFmpeg. And after I do that, I do another pass with FFmpeg, and I tell it to save it in the format PNG. Now, pings are images as opposed to video. So what it does is it fills a directory with numbered ping files. The first frame is 00000, and the second one is 00001. I also have it write out as it downsamples the sound into 8,000 samples per second mono. And I think it's writing it out as a 16-bit signed numbers, but in another program, I slurp in all of the ping files and the 8-bit PWM sound file and start to interlace them so that you've got 1,600 bytes of sound renormalized for the way it's going to come out of the sound port on the CoCo. And then that's followed by, I forget how many bytes, 6,144 or something like that, which is the exact frame buffer that we want to throw onto the screen. And then the next sound segment, and then the next frame buffer of image. And so the file just alternates with these, and the player is using a 8,000 hertz interrupt to play the sounds. And the main routine is loading the images. And after it loads the image, it looks at the pointer in the circular buffer for the audio to see which half it's in. And by waiting for it to get into that other half is how it's synchronizing the sound to the video.
It doesn't come out much in the demo, but sitting in front of this with the CM8 going, the sound really carries it. That's what drives the
Yeah.
video. It doesn't have as much impact in silence.
Yeah, it's too bad it gets probably turned up by the Zoom, because it really actually does sound pretty good unless it's quiet. There's a segment of 2001 where you've got the Earth and you've got the space station, and they're playing the Blue Danube Waltz, but they're playing it very quietly. And since we only have 6 bits of audio, and we're not doing like they do in MuLaw, where there's part mantissa and part exponent, so it can kind of adjust and still sound okay with quiet sections. Instead, we get more of like a buzzing noise. And
Right. You got 4 values and
yeah, but that's the CoCo. That's our beloved 6-bit mono audio.
So this is 160 pixels wide, right? 16 color.
I think that is 128. I can definitely take it to 160 on a 6309, but there's no 6309 optimizations running in there right now.
have any.
Do you hear any sampling rate harmonics? Because it's the frequencies like what 8,000 that you're using your audio samples.
I'm trusting FFmpeg to have done the appropriate filtering when it downsamples to 8,000. And so, no, you don't hear the kind of aliasing that you would hear if you fail to do that filtering.
Yeah.
Oh, this is Tron. This is the new Tron. I rather like the old Tron movie as well. But the light cycles, or whatever they call those.
Light cycles. Curtis asked, are you stack blasting any of the graphics or compression while transmitting?
Let me think. remember asking Curtis about stack blasting and presented some code, but I think the answer is I don't remember. I don't remember if it's actually I think it is. Yeah, I'm sorry, I don't know, but I'll have to go look. We would I would have since I wrote it in C and compiled it with GCC. And I can compile this with GCC in a very good optimization mode because it's not running under OS 9. This is bare metal, so it's being loaded at a fixed location in RAM. And GCC is doing my optimizations. I would have to override a block copy routine with a stack blaster routine, and that would be great to have in that environment. Yeah, I don't remember. We get about 25 frames per second in that life game in, I think it's P mode 3. It's a 128 by 96 4-color mode. And the idea is that would run on CoCo 1s, 2s, or 3s.
Right.
I really think about the limitations of like a 4K CoCo 1 and try to write anything to run on as many of these platforms as possible. And I would love to see that if you take your CoCo 1 and you plug in a CoCoIO card, that we can make it do a lot of things that you can't do with your CoCo SDC or with other solutions. And I even have I have a secret plan that I call level 0, and there's some initial code for this in the Fraveo repository, Nitrous 9 level 0, which is where, say you do have a 4K CoCo 1, we load a OS 9 program into the RAM, but every time it hits an operating system trap, well, it just sends packets out to the server to handle. And so it doesn't have the operating system, but it does run OS 9 commands there. Because, think of OS 9 as being an APIs rather than a product. And it's not too far off from, an old PDP or something that had a drum device. Drums were faster than disks. They could spin, but they were smaller and more limited. But Tommy's
Chris is
nobody
asking
can.
how much
Yeah,
ROM space?
Tommy's
Sorry,
perfect. Good. Yeah. That's cool to see on there, Tommy, like that. Let me get back to what I was talking about. Swapping programs out because you don't have much RAM. Hey, that's an old story in computer science. And if our Ethernet card is as fast as somebody's drum was back in the day, why not swap things around?
Won't know the difference. Hey, we're coming up on 50 minutes, so are this going to be good enough for this particular one? We move on to Tommy's stuff, or where are we at?
I'd say so. I mean, unless Henry's got something more to add, he's basically got all the news. You all have heard about my stupid programs 50 times.
This is a 64K ROM, right? It's like 27512. Your ROM.
It's just an 8K ROM.
ROM is 8K.
8K ROM. Okay.
Yeah, it fits in the C1000s and D1000s like a typical.
Where it's supposed to fit. Yeah, exactly.
Thing. Let me say like 60 seconds on future directions.
Mm-hmm.
What I like playing with is not necessarily what most of Coco Nation wants to play with. I like writing device drivers and making fundamental things work. Other people want to play games, and and that's fine. I run their spreadsheets and their conference booking applications. But I would like that to see a CoCoIO board in a Coco be as useful as Coco SDC is, be as useful as DriveWire is, be as useful as the up and coming FujiNet is. And I'm going to start putting more attention into getting compatibility with the DriveWire world, with that huge tree of wonderful software that's available for your CoCo SDC, and to to try to have bridges into the FujiNet world as well. It'd be nice if we could run FujiNet clients on the CoCo and connect to FujiNet services out there. And a lot of this stuff is layered well enough that it can be tunneled through. So talk to me if you've got ideas of your own.
Excellent.
So you're on the CoCo Discord, and you're on. I don't know if you're on Facebook, but you're on the CoCo Discord. So probably
Yeah,
the easiest
CoCo
place to-
Discord is the best. I'm not a regular Facebook.
Okay, well, I'm gonna.
Strict9 is my name on the CoCo Discord. You can figure it out, and or get in touch with Mark, Rick, anybody. They can forward things.
I'm pointed the right direction, and I am going to get back to doing stuff on the CoCoIO. I've been off on this game, trying to get this game up and going, and then I want to get a CoCoIO layer instead of DriveWire. So anyway, all these little projects.
Yes.
Well, I'm gonna cap this here. We got one more. I've got one more presentation. Thomas is going to take the last one now. I am going to stop the streaming and then restart it so it has the proper labels on there, because it's a lot of extra work to try to chase down changing all the labeling. So, so that means everybody out there in Streamland, except on Twitch, is going to have to go find the new stream. But you'll get an announcement. So it's all been working pretty good so far today. Anyway, say goodbye, everybody, and we will pick this up in 2 minutes with Thomas.
Bye, everybody.
All right.
Thanks, Henry.
Hey, bye.
All right. Thank you, Rick.